Hi viewers, in this session we are going to practice different models of questions in highway geometric design. So I am not going to solve the question entirely. I'll just give you the types of questions, types of models, and I'll explain you how to solve, and I'll give you hints wherever the students may make mistakes. I'll explain those things. So first, stopping side distance. I'll give you a simple question. If the design speed is 60 km/h and reaction time of drivers is 2.5 seconds, what is the lag distance if stopping side distance is given as 250 meter? So this is the question. I'll repeat. If the design speed is 60 km/h on a highway, the reaction time of driver is 2.5 seconds is given. 2.5 seconds is given. And what is the lag distance if stopping side distance is given as 250 meter? Suppose we have four options like 100 meter, 150 meter, some say 400 meter, and option D is none. So lag distance, what is the lag distance? Stopping side distance is lag distance plus braking distance, that we know. But this lag distance, what most of the people, what will they is, they'll simply multiply 60 into 2.5, that is 150 meter. So remember, this design speed is in km/h, but you have to convert it in meter per second and then calculate. So no need about this stopping side distance. We need this 60 km/h into, converted this into meter per second. Then none of these options is correct. Right? This is the mistake most of the people do. The next question we'll see. Similarly, in this stopping side distance, if the gradient of a road is increased, then what will happen to lag distance and braking distance? So what will happen? Gradient. Now the gradient has been given. So stopping side distance is equal to lag distance plus braking distance. Since the grade is given, we have to write F plus or minus N in percentage. That is, if the ascending gradient is there, plus n. If descending gradient is given, we'll put minus n. So now grade is increased, means ascending gradient plus n. Denominator has been increased. So what will happen? Total will be decreased. So braking distance will decrease. So the options may given be like this: lag distance and braking distance decreases, increases, stopping side distance decreases. Don't get confused. So denominator has been increased, so the braking distance decreases. Since the braking distance decreases, stopping side distance also decreases. So same is the case for descending gradient also, vice versa. Got it? And now overtaking side distance, we'll see. Overtaking side distance. Suppose design speed of an overtaking vehicle is some 80, say, and speed of an overtaken vehicle, say some 60. So what is overtaking vehicle? The vehicle which overtakes then another vehicle is this vehicle is here. So this is the overtaking vehicle. So 80, it overtakes and 80. And this is the overtaken vehicle and this is 60. Initially this vehicle is here. So we have D1 plus D2. Right? D1 plus D2. So D1, you know, if the time is given, so 80 km per hour, convert this in meter per second into the time. Plus, we know, overtaking vehicle, it is VB. Say this is A and this is the vehicle B. Then we know D2 is equal to VB into T plus half AT square, where T is square root of 4s by A, where A is the acceleration of this vehicle and S is 0.7 VB plus 6 meter. You know 6 is the length of the longest vehicle, wheelbase vehicle. So S. So remember all this. And also they may probably ask, what is the distance of overtaking zone? Minimum distance of overtaking zone, that is 3 times of, this is minimum. Minimum distance of overtaking zone is 3 times overtaking side distance, and desirable length of overtaking zone is 5 times. And if there is an opposite vehicle, then what happens? There comes D3, which is V of the design speed of the whatever the road has been given into T, this time taken from this vehicle to overtake and join this lane. Got it? And there may be no twists given on overtaking side distance. Almost there is no chance to give a different question in this topic. In stopping side distance, they may also ask regarding the braking efficiency. In stopping side distance, they may also ask regarding, if they given the data regarding braking efficiency, what will happen? You know the coefficient of longitudinal friction, denoted by small f. This is multiplied by, if the braking efficiency is mu, this is multiplied by mu into f. If the braking efficiency is, if they have given 50%, then what will happen to this f? 0.5 into f is the final longitudinal friction coefficient. Now we will see about radius of a horizontal curve. We know that E plus F, rate of superellation, plus coefficient of lateral friction, is equal to V square by GR, and this R is the radius, we know. We have two radius, that is limiting radius and desirable radius. So ruling and limiting. This E plus 5, we know E for plane and rolling terrain is 0.07. Coefficient of lateral friction can be adopted as 0.15. So we have two design speeds, that is ruling design speed and limiting design speed, that you have to remember and gather it from your memory and adopt this V accordingly. If it is a national highway or state highway, then this limiting is 80, V is 100 is the ruling, 80 is the limiting. Ruling design speed and limiting design speed. Accordingly, you calculate and find your answer. Now, rate of superelevation. If a question is asked like this, national highway passing through rolling terrain, has two horizontal radii, say some 250 meter and 150 meter. And 150 meter. Find rate of superelevation. So now we know how to find rate of superelevation for mixed traffic conditions. We have step by step. We have first step. We know E plus F is equal to V square by GR. First step is assume there is no lateral friction and find E for 75% of design speed. We know at the horizontal curve, generally the speed of the vehicles will get decreased because there is a curve. So that we have taken as 75% of the original speed, and we will calculate. If this value is less than 0.07 for plain and rolling terrain, then whatever the value comes here, you adopt that. The question is over. We have calculated. But remember, minimum rate of superelevation. In the last class we have seen, minimum rate of superelevation is the camber. That is cross slope of the whatever road, cross slope of the road is the camber. That you have to check. If this value is more than the minimum camber, then it's fine. So now suppose calculated E is more than 0.07 because this is rolling. Then go to next step, that is adopt E as 0 and find F. Adopt E as 0.07 and find F, that is V square by GR minus 0.07. Okay. Now if F is less than 0.15, that is coefficient of lateral friction, then adopt E as 0.07 and the answer is over. If this will not happen, then what will happen? If this doesn't take place, then go to the next step. What is the next step? Step number 3. This design speed should be restricted. So if there is a curve, these two we can't adopt. The next step we are going, put a signboard and whatever the design speed comes here, allowable design speed, VA is allowable speed at this curve is square root of 0.22 GR. Remember, what is this? Allowable speed square root of 0.22 GR. Whatever the speed comes here, suppose some 35, we got the answer like some 35. So put a signboard here and 35 km/h means you have to reduce the vehicle's design speed is reduced and you have to be careful. That is the meaning of this signboard. This is how you calculate rate of superelevation. So 3 points you have to remember, this one and this one, and minimum camber. Camber chart you have to remember for high intensity of rainfall, low intensity of rainfall, what is the camber? Generally you may be asking about highways only. Highways means high type bituminous roads only. Highways are generally constructed high type bituminous roads, that is 1 in 50 for high intensity of rainfall reasons, 1 in 60 for low intensity reasons. Now, once superelevation has been adopted, the next topic is extra widening. So, generally extra widening they don't ask the direct question. So the question may be like this: on a 2-lane highway, say undivided highway, on a 2-lane undivided highway, in a plain terrain with limiting design speed, what is the total width of road at a horizontal curve of say some 200 meter. So you may feel that the data is insufficient, but there is sufficient data in this. What is the total width? So we know for a 2-lane road, undivided road, we have 7 meter as the width. But the total width has been asked means we have to add extra widening to it, which is NL square by 2R plus V by 9.5 square root of R. L we know we have to adopt 6 meter, and V is given, R is given, and number of lanes is also given, is 2. So you have to calculate extra widening, and the answer comes as like this: W plus WE is the answer. Got it? Plain terrain, limiting speed. What is the limiting speed? 100 is the rolling speed, 80 is the limiting speed. Adopt 80 here, L. So extra widening is 2 into 6 square by 2 into 200 plus 80 divided by 9.5 square root of 200. Add this, you will get the answer. Clear? I am just giving the hints and possible models, and you better refer any textbooks or past question papers and do it yourself. That would be fine. Now, horizontal element is over. Next session, we will see one more point. I forgot regarding stopping side distance. Most probably stopping side distance is the repeated question. Stopping side distance, whatever we calculate, is for a one-way road. Means there is no opposite traffic. If the opposite traffic is allowed, so suppose there is a 2-lane road, which means we have 2 directions and there is no opposite vehicle. Sometimes they may ask, one road is closed and the 2-way traffic is allowed on a single lane, which means stopping side distance becomes intermediate side distance, means stopping side distance for both the vehicles. That is 2 times stopping side distance. Remember this is the repeated question in the GATE exam. Clear? Next session we will see vertical alignment. Means, we will see.